The product used in this ME110 product case study video is a 3-jaw lathe chuck. Team members are Marshall Hoaglan, Ryan Thomas, and Tyler Broder.
This 3-jaw scroll chuck is a self-centering chuck used to hold workpieces concentric to the spindle axis to be machined on a lathe.
The first component we'll examine is the chuck body. The lack of draft angles and the relatively smooth surface finish implies the chuck body was not created by casting. The lack of uniform cross-section also excludes extrusion. Evidence suggests that the lathe chuck body was forged and then finished with machining processes. Concentric tool marks on the hub of the body appear to have been made by rough turning and facing. The threaded holes in the body were more likely made with cutting taps.
The rough and dull surface finish of the backplate and the included draft angles imply that it was sand-casted and then faced. This part was likely not forged due to the poor surface finish and was also not extruded due to the lack of constant cross-section area.
The inner diameter of the scroll plate has an excellent mirror-like surface finish. The surface finish is difficult to achieve with a machining process such as boring or reaming and was most likely accomplished with the finishing process of honing. The tool marks imply that the bevel gear was cut with a typical gear cutting machine, but the spiraling rectangular channel of the scroll gear must have been done on a vertical mill.
The lathe chuck jaws and jaw caps have perpendicular features that tightly fit together when assembled. The lack of any draft angles and the relatively tight tolerances of the components implies that casting or forging alone were not used. Horizontal milling was likely the process used to create these features. However, the curvature of the teeth on the jaw that interface with the scroll gear must have been made on a vertical gear like the scroll gear.
The bevel gear shows no tool marks that would be left behind by gear cutting. Forging is not likely since it would have been an unnecessary expense since the bevel gear does not require the increased strength and hardness advantages of forging. The bevel gear was originally made by casting as suggested by the inherent draft angle of the whole part. Although no parting line is evident, it was likely machined away when the bevel gear was finished turned at both ends to have good surface finishes to rotate on.
The chuck wrench and wrench handle were most likely made by extrusion due to their constant cross-sections. Although the surface finish is smooth and consistent, grinding would be an unnecessary expense for loose-fitting parts such as these. The squared end on the wrench was most likely made by open die forging.
The higher strength, minimized waste, and higher production rate of rolled threads versus cut threads implies that the threads of these screws were rolled. The head of the cap screw was likely formed with a combination of heading to increase the diameter and piercing to get the hexagonal shape of the cavity. This concludes our case study.